Alright, so here's where we left off last time. We started by looking at the methods of evaluated limits. I would say that the methods of evaluated limits are direct substitution, factorizing, and conjugate. Alright, let's have a look at those. Alright, so direct substitution, example 2, we're to find the limit of x squared plus 4x plus 1 as x approaches 1. Alright, so for direct substitution, it's simply wherever I see x, I'm going to take out x and put 1. So this would be equal to 1 square plus 4 times 1 plus 1, which would be equal to 1 plus 4 plus 1 would be equal to 6. So the limit of x squared plus 4x plus 1 as x approaches 1 is 6. Example 3. Example 3 is asking us to find the limit of x squared minus 3x over x cubed plus 4x plus 1 as x approaches 0. Alright, so as x approaches 0, wherever I see x, I'm going to take out x and put 0. So this is 0 squared minus 3 times 0 over 0 cubed plus 4 times 0 plus 5. So at the top, I'm going to have 0, and at the bottom, I'm going to have 5. Alright, so the limit of x squared minus 3x over x cubed plus 4x plus 5 as x approaches 0 is 0. Alright, number 4, the limit of 3x squared plus 1 to the 4th power multiplied by t plus 2 to the 3rd power as t approaches minus 1. Now, if I wanted to, I could go limit law by saying that this is equal to the limit as t approaches minus 1, 3t plus 1 to the 4th power multiplied by the limit as t approaches minus 1 of t plus 2 all raised to the 3rd power. So if I wanted to, I could have done that. And so by direct substitution, we'll have what? 3 times minus 1 times minus 1 plus 1 raised to the 4th power multiplied by minus 1 plus 2 raised to the 3rd power. So this would be minus 3 plus 1, which is minus 2 to the 4th. Minus 2 to the 4th, I'm guessing, would be 16. Alright, multiplied by 1, minus 1 plus 2, which is 1 to the 3rd, which is just 1. So the limit here is equal to 16. Alright. So again, if I wanted to go limit law, I could say that this is equal to the square root of the limit as t approaches 2 of t cubed plus 3t squared plus 5. And this would be equal to the square root of as t approaches 2, we're going to have t we're going to have 2 to the 3rd plus 3 times 2 squared plus 5, and that's going to be the square root of 8 Alright, there must be some space around the next page for this. There isn't any. Alright, let's go back. So this will be the square root of what? The square root of 8 plus 12 plus 5. So this would be the square root, I'm guessing, of 25, which is 5. So the limit of the square root of t cubed plus 3t squared plus 5, the square root of that, as t approaches 2, is 5. All right, let's look at um, evaluating limits by factorizing. All right, example 6. All right, so the limit here would be equal to, let's factorize both numerator and denominator. This would be equal to the limit as x approaches minus 2 of, if we factorize the top, we're going to have what? We're going to have x here, x here. I'm getting 3 and 2. 3, 2, plus, plus. And this is over x plus 2. Here, x plus 2 cancels x plus 2. So we're left with the limit as x approaches minus 2 of x plus 3. And now by direct substitution, this would be equal to minus 2 plus 3, which is equal to 1. So the limit of x squared plus 5x plus 6 over x plus 2 as x approaches minus 2 is 1. I think that this is an example of one of those functions that the limit exists, but the function itself never reaches that value. All right, here we have what x cubed plus 8. All right, so we need to remember how to factorize x cubed plus 8, or how to factorize the sum of 2 cubes. All right, I think this is how it factorizes. So this is the same as saying the limit as x approaches minus 2 of x plus 2. So that's the same as at the bottom. And this is what? X squared minus, if I'm not mistaken, two x plus 4. Right. We're not working as it should. I'm not 100% sure that this is correct, but let's assume it is correct. So this cancels this. So what I'm left with is the limit as x approaches minus 2 of x squared minus 2x plus 4. And so by direct substitution, I end up with, I'm going to end up with minus 2 squared. Wherever I see x, I'm going to put minus 2. Minus 2 times minus 2 plus 4. And this is equal to 4 plus 4 plus 4, which is equal to 12. All right. All right, conjugate method. All right, so let's evaluate. At the bottom we have a surd, so let's get rid of the surd by multiplying the numerator and the denominator by the conjugate of the denominator. All right, so this would give me the limit as x approaches 25 of x minus 25 multiplied by the conjugate of the denominator, which is what? The root of x plus 5. And at the bottom, the root of x minus 5 times the root of x plus 5. X minus 25 at the bottom, root of x plus 5. So down by the bottom, if we multiply by the bottom, you'll notice that we have the difference of two squares. If we multiply root x by root x, we get x minus 5 by 5 is what? 25. Alright, so we can note that x minus 25 cancels x minus 25. So this is the same as the limit as x approaches what? 25 of the root of x plus 5. And by direct substitution, this is equal to the root of 25 plus 5, which is equal to 10. Alright, example 9. Alright, we're asked to evaluate the limit of the root of x plus 8 minus 3 over x minus 1. So this is saying the limit as x approaches 1 of the root of x plus 8 minus 3 multiplied by the root of x plus 8 plus 3 over x minus 1 multiplied by the root of x plus 8 plus 3. Alright, let's see where this is going. This is the limit as x approaches 1. At the top, I'm going to have what? X plus 8 minus 9. That's a difference of 2 square. And at the bottom, I have what? X minus 1 times the root of x plus 8 plus 3 is equal to the limit as x approaches 1. At the top, I have what? X minus 1. Down the bottom, I have x minus 1 multiplied by x plus 8 plus 3. Alright, so x minus 1 in the numerator and denominator cancels. And by direct substitution, this is equal to 1 over the root of 1 plus 8 plus 3. This is equal to 1 over the root of 9 plus 3 is equal to 1 over 3 plus 3, which is equal to 1 over 6. Example 10. Example 10, this says evaluate x minus 6 over the root of x minus 6 as x approaches 6. So this is equal to the limit as x approaches 6 or x minus 6 times the root of x minus 6. So I'm going to multiply the numerator and the denominator by the root of x minus 6. Alright, so this one we have getting rid of the root in the denominator. So this is going to be equal to the limit as x approaches 6 of x minus 6 times root x minus 6 over x minus 6. So root x minus 6 times root x minus 6 is x minus 6. The x minus 6 cancels. This is equal to the limit as x approaches 6 of the root of x minus 6, which is equal to, by direct substitution, the root of 6 minus 6, which is the root of 0, which is equal to 0. Alright, example 11. We are to find the value of the limit of x minus 14 over 4 minus the root of x plus 2 as x approaches 14. Alright, so this is the same as saying the limit as x approaches 14 of x minus 14 multiplied by 4 minus the root x plus 2 over 4 minus the root x plus 2, 4 plus the root of x plus 2. So it's x plus 2 at the top. Alright, so multiplying by the conjugate. So we're going to end up with the limit as x approaches 14 at the top, x minus 14, 4 plus the root of x plus 2, all over. At the bottom we're going to have the difference of 2 squared, so this is 16 minus, and we have x plus 2. So this is equal to the limit as x approaches 14. Up at the top we're going to have what? Let's go back a little. X minus 14. Okay. Alright, so at the top of x, one more time. Well, x minus 14. Okay. So of x minus 14 at the top, and then 4 plus the root of x plus 2, and down by the bottom we have 16 minus x minus 2. So we see. Alright, so we're going to equal, this is equal to the limit as x approaches 14, and we're going to have x minus 14 at the top, and then this is 4 plus the root of x plus 2. And down by the bottom we have 14 minus x. This is equal to minus the limit as x approaches 14 of 14 minus x times 4 plus the root of x plus 2 over 14 minus x. So these two cancel out each other. Alright, and then now by direct substitution, this is equal to minus, and we have what? 4 plus the root of 14 plus 2. The root of 14 plus 2 is the root of 16, which is 4. So 4 plus 4 is 8. So this is equal to minus 8. Alright, so for that video, let us stop here, and we will continue in the next video.